let's see how to calculate the maximum and minimums of a given function. The process is very clear and you must just follow the steps. So I'll write the steps first here. First step to calculate the maximum and minimums is to do the first derivative, to differentiate the function. So the first step would be to calculate y prime. The second step is to make that derivative equal to 0, and that gives me certain values. Okay, so that will give me a number of values depending on the power of the index of the function. Okay, the third step would be to calculate the second derivative, so differentiate the first derivative, and then the fourth step would be to substitute those values in the derivative and see if they're greater or less than 0. If the second derivative is less than 0, it is a maximum. If the second derivative is less than 0, more than 0, greater than 0, it's a minimum. And then if it's equal to 0, right now at this level, there's an influx point, but right now at this level you won't have to consider it, and you won't have those cases. Just remember then, first derivative, equal that first derivative to 0, calculate the points that we were given. Second derivative, substitute those points in the second derivative, see if they're less than 0 or more, greater than 0 or less than 0, and if it's less, it's a maximum, and if it's more, it's a minimum. It's the other way around, and we'll try to explain in a minute why. So let's look at an example. If we have, for example, an easy function like 3x squared minus 6x, we will follow those steps. So number one, we want to calculate the maximums and minimums in that function. Another important thing, remember that you have as many, the function cuts the x-axis in as many points as the index of the function, the greater index, and you have as many maximums and minimums as the index minus 1. So this function has one maximum and minimum, or minimum. A straight line, for example, which has the power of 1 minus 1 is 0, has no maximum or minimums. Okay, it's easy to remember. Let's follow the steps. Step 1, differentiate. Y prime is 6x minus 6. Yes. Second step, that derivative will equal it to 0. Okay. So that gives us that 6x minus 6 is 0. So if we factorize, that 6 equals x minus 1 equals 0. So the solution for that is x equals 1. Every time we have something multiplying and it's equal to 0, either one factor is equal to 0, which in this case makes no sense, or the other factor equals to 0, so in this case it's 1. You can also think of it, if we put 1 there, the multiplication is equal to 0. So we have a maximum or minimum in x equals 1. How do we know which kind of point it is? We do the third step, calculate the second derivative. It's differentiate the first derivative, so it's easy. So that's 6. 6 is greater than 0, so that's a minimum then. Remember, it's the other way around. Okay? So, that's finished. We calculated, we've joined now here the 3 and 4 step. So that's 6, and 6 is greater than 0, so that's a minimum. Okay? So that's easy. You can now think of it, you can draw the graph. this is a curve where we know the shape of the functions that are x squared. They're this shape or this shape. Okay. So if we are if we want to draw that graph, we'll calculate if it's x equals to 1, we'll calculate the y. So if we calculate the y there, it's 3 times 1 minus 6, which is 3 minus 6, which is minus 3. So this means that the point is, that is the minimum in this case is to 1 minus 3. So if we go here to minus 3 and here to 1, it means this is the minimum. Okay? So the function just goes that way because it's a minimum. We already know it does this because it's a minimum. Where does it cut? Well, we'll remember how to solve equations, quadratic equations, so we equal that to 0 to find where it cuts the x-axis. Again, if we factorize that, we can get 3x is x minus 2, so that gives me 2 points, which is x equals 0, x equals 2. So x equals 0 and x equals 2 is where it cuts the x-axis, and that function is that way. Okay? So now I'll use this, you can see that finding the maximums and minimums is an easy way to draw a function. If we also find the points that cut the x-axis. I'll explain now why I'll give you an idea why the second derivative follows this rule. If you remember, the first derivative was the slope of a function, and the slope in a curve changes for each point. So if we want to draw the slopes here do something like this. You change in the minimum or maximum, they're 0, they have no slope, and then they increase. Okay? So if the first derivative is the slope of the curve, the second derivative is the slope of the slope. So it means how is it growing, how the slope is growing for each point. If you see here in the minimum, the slope changes from negative to positive, so it grows. So that's as the slope grows, the second derivative is greater than 0, it goes up. That's why the rule is like that. If it's if the slope if it's a maximum, then the slopes do something like this, and then you can see that the slopes go from positive to 0 to negative, so they decrease. It's a negative slope, so the negative slope of the slope is the second derivative, which is negative, and that's why it's a maximum. But that's just what it means. You don't have to understand it. The real important part is to know those steps and know how to solve it. It's important once you calculated the x of the minimum and with the first derivative, if you need the y, substitute the x in the function and not in the first derivative like some people do. But then to calculate if it's a maximum or minimum, you have to use that x in the second derivative. So don't get confused with the steps, because that's where the mistakes come. Now let's do some other example, a bit more complicated. You can remember the steps, you have them in the video. So we'll use this function, y equals x to the power of 4 minus 8x to the power of 2 minus 9. Let's do the steps. First step, differentiate that function, so that's 4x cubed minus 16x. Easy. Second step. You can try and do this, you can stop the video, try and do this on your own and see if you get to the same result. So, second step, that's equal to 0, so that's 4x cubed minus 16x equals 0. So, as always, factorize, that's 4x, common factor of x squared minus 4 equals 0. When two or more factors are equals to 0, to solve them, So to solve the equation, we have to put one of the factors equals to 0, the other factor equals 0. This gives us x equals 0 because of the same reason. Both one of the factors equals 0 for which is can be, and x equals 0. So you have to solve this. Two ways to solve it. You either say x squared equals 4, so that means that x equals plus or minus, don't forget, square root of 4, which is plus or minus 2. The other way, which I like best to solve this, is that this is a known factorization, because it's this is the power of 2 and this is the minus something that is the square of something, and that's x plus a times x minus a gives x squared minus a squared, which is the case. So we can factorize it easily, and then those two give x equals minus 2, x equals 2. Okay? So either way, we have how many maximums or minimums? As we said, we have 4 minus 1, 3. 1, 2, and 3. Okay? So now, third step, second derivative. Bum, bum, bum. 12x squared minus 16. Now, see, this changes. It is not constant like the other case. This changes, the second derivative changes depending on the point we're dealing with. So we'll go to the fourth step, and we have to calculate that for each point. So let's go to the first point. Second derivative calculated for x equals 0. That gives me minus 16, which is less than 0, which implies this is a maximum. Okay? Second point, second derivative of minus 2. We'll do it in 2 and it's the same. In this case, second derivative of the 2, that means 12 times 4 minus 16. Okay? That means that's equal to 8, 4 minus 16. So that's 32. Okay? If I'm not wrong, 48, that's 38, and that's 2. Yeah. Let's check acres in the blackboard. Yeah. So, that is greater than 0, so it's a minimum. And then if we calculate the second derivative of the other point, we substitute, but in this case, as I said before, in this case it doesn't happen always. It's the same, which is 32, just pure chance. It is a minimum 2. Yeah. So if we only had to calculate the maximums and minimums, we have them. X equals 0 is a maximum, and x equals minus 2 and x equals plus 2 are minimums. Okay. If we wanted to draw them, we would have to calculate how much the y's are for each point. So y of 0, we substitute again this in the original function. That gives me minus 9. So the first point is 0 minus 9. For the 2, we get 2 to the power of 4 minus 8 times 4 minus 9, which is minus 25. Okay, and for the minus 2, it's the same as they are squared, so that's minus 2 to the power of 4 times 4 minus 9, it's the same, it's minus 25. Okay? So we get the point 2 minus 25, and we get the point 2 minus 2 minus 25. Let's draw that. So, function, we have the 0 minus 9, so here it's 0 and it would be a minus 9 here. Let's do it here. Obviously we're not using scale. And we know that this is a maximum, so if it's a maximum, the sides go downwards. Okay? The other 2 are 2 and minus 2, okay, and these are over down here, minus 25. Obviously, again, we're not using scales. So, we're not using just to scale, and then there's some minimums with the extremes go upwards. So, this does something like that. How will it go? How will it go upwards? Well, we would just have to calculate the where those solve that equation equal to 0, make it equal to 0, calculate the x's, and we would know how it cuts here, but I'm not interested now. The important part is that this equation has 3 maximums or minimums, 2 of them are minimums, 1 is a maximum, and we have done it through those steps. Okay? You can do more exercises through the online academy, or your teacher can send you exercises.